This tutorial will demonstrate how to use the volumetric light features added in RayTK version 0.17. Start by dropping the toolkit talks into your project. Make sure to use at least version 0.17. There's a link in the video description. We're going to set up a surface using some Helix SDFs and a renderer, and then we're going to add the volumetric lighting. Open the palette using the Alt-R shortcut. Create a Helix SDF. And create a RayMarch Render 3D. And connect the helix to the first input. Then add a null top to the end so you can see the output. For preview purposes, I'm going to set the resolution here so that it fits in this panel here, but feel free to set it to whatever you want. All right, on the renderer, switch off shadows. We aren't going to be using shadows in the scene, and switching it off will significantly improve performance, especially once we add the volumetrics. Create a look at camera and connect it to the second input, the camera input, on the renderer. Set the Z position to 9 and the field of view angle up to 70. Next, create a point light and attach it to the third input, the light input on the renderer. Set the Z position of that to 2. Now that we have the basics of the scene set up, we're going to make some changes to the SDF. On the Helix SDF, set the radius to 2 and the spread to 1.5. Create a second Helix SDF. And on this one, set the radius to 1.5, the thickness to 0.1, and the spread to 1. Then create a combine and connect both helixes to the first two inputs. And then connect the combine to the first input on the renderer. Set the combine mode to smooth union and set the blend radius to 1. So we now have two helixes blended together, but they're mostly just overlapping in the middle area. So to get more interesting interactions between them, we're going to flip one of them so that they spiral in opposite directions. So create a flip operator. Keep the axis as X and connect it between the first helix and the combine. Now create a basic material and connect it between the combine and the renderer. We aren't going to be focusing too much on the material here. We're just going to use it to adjust the color, and then we're going to focus more on the volumetric aspect. So set the sky amount down to 0, and this is that fake sky color lighting that the basic material provides, but we're not going to be using that here. And then for the base color, set that to a dark blue, like 0.2, 0.3, and 0.5, or to some other color that if you prefer. Well, we're now going to add some motion to make them spin at different speeds. So create a rotate operator and insert it between the flip and the combine. Then add another one for the second helix, so between that second helix SDF and the second input on the combine. This will let us rotate them independently of each other. Now, as a shortcut, we could use the spin operator, which provides a kind of handy way to have this sort of animation built in, but for reasons that we'll cover later, we're going to stick with using the rotate operator. So to add the animation, since it isn't built in this operator, we're going to have to do that with chops. So create a constant chop, and then add two channels, an R1 and an R2 for the two different rotations. Add a math chop and set the multiply up to 180 so that we get values that are in a useful range for rotation angles. Then add a speed chop, and finally a null. I'm going to name the null rotates. Then drag the R1 channel onto the Y rotation on the first rotate operator. Use chop reference. And then do the same thing with the second rotate operator and the second channel. Try playing around with different values in the two rotate settings, and you can see that you're getting two different rotation speeds for the two helixes. Now I'm going to set those back to 0 just for now, but feel free to keep them running if you want. So we now have our SDF set up and we're ready to move on to the volumetrics. Volumetric lighting allows you to create areas of space where extra light gets added as rays move through the scene. It isn't a new light source itself, meaning that it doesn't light up surfaces. Instead, it's more like glowing areas floating in space that show up in the renderer but allow light to continue on through them to hit surfaces. There are some significant performance limitations that you'll need to keep in mind as you're working with it. Start by creating a volumetric raycast. This is the core of the volumetric system. So it's an extra layer of processing that can be added onto the renderer. So on the renderer, go to the settings page and enable secondary raycast. Then drag the volumetric raycast operator onto the secondary raycast parameter. If you want to, you can also add a null dat to the end and drag that on, or just use the operator directly. So suddenly everything is filled with light, and that's the end of the tutorial. Just kidding. So what's happening here is that we haven't given it a specific area where it should apply, so it's showing up at full brightness everywhere in the scene. Now if you adjust the level on the volumetric raycast and put it really far down, you'll start to see the shape within there. But this is still applying to the entire space of the scene. What we want is to limit that fog to certain areas of the scene. And to do that, we're going to create a light volume. And connect that to the volumetric raycast. So the light volume is a way to define an area where volumetric lighting is applied, and also some properties of that, including color and optionally a field that can control the color at different points in space. So right now it's still applying to the whole scene, and that's because we haven't given it a bounding volume. Now make a copy of the second helix SDF and the rotate, and connect that rotate to the first input, the bound volume input on the light volume operator. Now you may be wondering why we can't just connect that original SDF, and you can try that, but you'll get error output, and that's because there are currently some limitations in the system that won't allow the same operators to be used both for the surfaces part of the scene and for the volumetric light part of the scene. And this is why we use the rotate operator instead of spin, so that we can have these two different copies that are kept synchronized with each other because they're controlled by the same channel. So switching back to the copy of that SDF so that the volumetric has its own set of operators to work with. So hopefully this may be fixed in future versions of the toolkit, but if you see that kind of error output when you're connecting things up to the light volume, make sure that you aren't also using those same operators elsewhere in the scene. Right now, we aren't seeing any areas of the scene being lit up though, and that's because the volume that we're specifying is entirely contained within a helix that's also being used as a surface, so it's entirely inside that helix. So on the helix operator, increase the radius to 1.8. Now we still aren't seeing anything, and that's because on the volumetric raycast here, we left that level really low, so I'm just going to reset that to 1. So you can now start to see it a little bit in there, but it's still mostly overlapping with the other helix. The light volume operator uses this SDF to define the area where that lighting gets applied. Now, it also has some settings that it can use to adjust how it interprets that barrier. So in the offset here, increase that to 0.4. And what that does is expand out the surface of the volume that it's using. This is similar to the round operator. So this still has a fairly hard edge to it though, so we're going to increase the blending here to 0.8. And what that does is smooth out the transition from inside that volume to outside of it, so it fades over a distance rather than just cutting off at a point. What we're seeing right now is that as rays pass through the areas of that helix. They're adding some additional light before they continue on and either hit the surface of the other helix there or continue out of the bounds of the scene. So the more time that each of those rays spends within the volume, the more light it picks up. And that's why on the sides here, it's brighter than in the middle, because on the sides, it's got a longer distance where it's within that volume. Right now, the light volume is always just adding white light. Currently, it isn't even paying attention to the color of the light source. To enable that, on the light volume here, enable Use Light Color. And then if you adjust the color of the light source, you will see that in the rendering there. But it's still applying that same color everywhere without any variation to it. So to do that, we can use a field to provide different colors at different points in space. So we're going to create a sort of bullseye pattern stretched vertically, so it's like a set of concentric columns. So the pattern is going to be based on the distance from the y-axis. Create a point distance field. And connect it to the second input on the light volume, the color field input. So this field produces the distance from some center position specified by this parameter here. Now, as you might expect, that distance just keeps increasing further as it gets further away from the center. And what we want is a repeating pattern. Create a wave field. Connect the distance field to the first input, the coordinate input on the field, and then connect the field to the light volume. So we now have a set of kind of concentric spheres coming out from that center point. And if you increase the period here and adjust the phase there, you can see how it's kind of emanating from that center point and coming out in spheres. So what we want, though, is to only use the distance from the y-axis. So on the point distance field, we're going to change the axes here from using all three to just using x and z. So now, if we adjust the wave phase here, you can see that it's kind of coming out from that center axis. But vertically, it's kind of remaining the same. And the values that this wave produces are coming out of a sine wave, which produces a -1 to +1 range. So we're going to increase the offset to 0.5 and then decrease the amplitude so that we're getting a 0 to 1 range instead. So we're currently controlling the brightness of that color, but not the actual hue of it. And that's because this field here is just producing a single value, which is being used for all three color channels, red, green, and blue. Create a color ramp field. and insert that between the wave field and the light volume. This operator is like a ramp top, where it takes in values from a 0 to 1 range, produces a color between two other colors specified in the parameters. So try changing the colors here, and you'll see that it's doing a blending between this first and second color. So for the first color, I'm going to use a kind of dull orange, so 0.6, 0.2, and 0. And then on the second one, I'm going to use kind of a pale yellow, so 1, 1, and 0.6. So we're going to add some animation to this to get some movement in that wave pattern. So similar to what we did with the rotation, create a constant chop. We're going to name the channel here phase. And we don't need to rescale this because phase is typically dealt with in a 0 to 1 range, so we don't need to scale it up to an angle like we do for rotation. So we're just going to create a speed chop, followed by a null, and I'm going to name this phases. Then on the wave field, I'm going to drag this channel onto the phase parameter and use chop reference. So if you increase the setting here, you will see the pattern moving there. You can try negative values to have it go in the other direction, or whatever you'd like. All right, and that is our scene. So to recap, we're creating the surface using two helix SDFs. We are flipping one of them, and we're rotating both of them independently using two different speeds of rotations set up through these chops, and then combining those using a combine operator with smooth union. We're then using a basic material to adjust the base color and running that into a renderer with a look at camera and a point light. To add the volumetric lighting feature on the renderer, on the settings page, we switched on Enable Secondary Raycast, and we created a volumetric raycast operator and dragged it onto this secondary raycast parameter here. Then to define the area where that lighting gets applied, we created a light volume, and we attached an SDF to the bounds input, and we're using a copy of that helix and rotate. And remember that you can't currently reuse the same operators in the main part of the scene, the surface part, and the volumetric part. We're then using a field to control the color of the light at different points within this volume. And that's based on distance along the X and Z axes from that center Y-axis, with a sine wave pattern being mapped to a color range using a color ramp field. So there are still more aspects of the volumetric lighting features which will be covered in later tutorials. Until then, you can try different types of fields and SDFs to define the volume. You can also create multiple light volumes and combine them using combined fields or composite fields before connecting it to the volumetric raycast operator. You can also remove the main surface from the render entirely and have it just use the volumetric part. Or you can combine the two have both a regular surface and the volumetric aspect. For now, I recommend avoiding using shadows for the light volumes unless you're okay with extremely low frame rates or possibly crashes. Hopefully that will be optimized in future versions of the toolkit, but for now, I recommend sticking with scenes that don't involve shadows. Thanks for watching. I look forward to seeing what you all create. If you have any questions or suggestions, you can either leave comments here or message me on Instagram or Facebook, or in the RayTK channel on the Touch Designer Discord. Check the description for links to all of those. When you post your work about this, if you add the RayTK tag to your posts, the rest of the community will be able to find those more easily, and we'll get to see what you're making. See you next time.